Dried wool bales are fed into a fiber blending machine. Each batch, differing in color, fineness, or origin, is precisely weighed and mixed by rotating rollers with spiral blades that separate fibers clumped during drying. A mist system keeps the air humid and static-free, while sensors control the speed for perfect uniformity. The fibers emerge soft, light, and elastic, ready for the next mechanical stage. Entering the structural formation phase, the dried wool is fed into the carding section, where loose fibers are realigned into a single uniform direction. The material passes through the carding machine, equipped with multiple metal tooth rollers, spinning at different speeds to create controlled friction and pulling force. Through this continuous motion, tangled fibers are separated, straightened, and gradually refined. Throughout the process, dust extraction systems and electronic sensors remove short fibers, fine dust, and impurities left from previous cleaning stages. As the material exits the chamber, it emerges as a thin, continuous web of fibers that is automatically rolled into soft slivers of consistent thickness and weight. Carding restores the wool's natural structure and enhances the cohesion between fibers, a critical factor determining the smoothness and durability of the final textile. In many small-scale workshops or traditional handcraft studios, artisans still preserve the ancient art of hand carding using metal combs. Two brush-like paddles covered in fine steel teeth are interlocked and pulled apart repeatedly, a motion performed dozens of times until every fiber lies perfectly parallel. Though time-consuming, this manual technique allows for delicate control of tension and pressure, preserving the wool's natural elasticity, sheen, and texture in ways that machines can hardly replicate.
The stitching here needs to be reinforced slightly to handle the...
Once the combing stage is completed, the long and refined wool slivers are transferred to the spinning section, the critical phase that determines the strength and fineness of the material. Here the fibers enter a multi-roller spinning frame, where each roller rotates at a slightly different speed to apply a gradual drafting tension. The front rollers hold the fibers steady, while the rear rollers accelerate slightly, drawing the sliver thinner while maintaining its elasticity and internal cohesion. Before the twisting unit, the surface of each strand is coated with an ultra-thin layer of spinning oil, reducing friction and preventing static buildup caused by continuous movement. As the fibers pass through the central twisting assembly, they are tightly bound together into a unified strand, forming a structure that is both strong and resilient. The degree of twist is monitored by tension sensors, ensuring perfect consistency along the entire length of the yarn. Next, the finished yarns are wound onto large bobbins and later rewound into smaller spools of standardized size. Optical scanners inspect each strand in real time, detecting thick spots, weak points, or over-twisted sections. Any flaws are automatically trimmed and rejoined using heat fusion, producing smooth, seamless joints nearly invisible to the naked eye. In smaller workshops, traditional artisans still preserve the heritage of hand spinning with a spinning wheel, relying on tactile control to adjust the twist intuitively. This slow and deliberate method yields yarns with a distinct organic character, often reserved for high-end handcrafted woolen products. The final yarn emerges with exceptional tensile strength, smooth texture, elasticity, and structural integrity, the result of precise engineering combined with generations of craftsmanship. In the next stage of production, the wool yarns, now refined to the ideal balance of fineness and strength, enter the weaving system, where the material transforms from loose threads into a unified textile structure. Before the process begins, automated sensors measure the tension, humidity, and density of the yarns to ensure stable operation throughout the weaving cycle. The first task is warping the yarns onto the loom. Thousands of strands are threaded through needles and heddles, forming the structural foundation of the fabric. Each strand must align precisely, as even the slightest deviation can disrupt the intended pattern. Once the warp is properly set, the weft threads are interlaced mechanically by a shuttle or airjet system, then compacted firmly by the reed. locking them tightly with the warp. The loom operates at high speed, yet every movement is monitored by fault detection sensors. If a broken yarn, loose tension, or sequence error occurs, the machine halts instantly, allowing operators to correct the issue. When the fabric reaches its standard length, it is wound onto a take-up beam and moved to the inspection area under bright lamps. Minor flaws, such as knots, dark specks, or uneven tension, are corrected by hand. At this point, the woven wool fabric has achieved a solid structure and uniform surface, serving as the essential foundation for the finishing treatments that will follow in the mill. The raw wool fabric is transferred to the finishing department, where its structure is stabilized and its surface texture refined. The process begins with fulling, immersing the fabric in warm water with gentle agitation, allowing the wool fibers to interlock naturally. This step increases thickness, density, and thermal insulation. Next, the fabric passes through fine carding rollers equipped with delicate metal pins that smooth the surface and remove any loose fibers. Certain batches are dyed according to design specifications, then steamed to set both color and dimensions. Finally, the fabric is dried at a controlled low temperature to preserve its softness, elasticity, and natural luster. By the end of this sequence, the once rough textile transforms into a smooth, resilient material, ready to become everything from tailored coats to luxurious blankets. In the final stage, finished wool fabrics move to the cutting and sewing section, where material begins to take the shape of a product. Inside the climate-controlled room, the fabric is stabilized for temperature and humidity before cutting. Automated rotary blades follow digital templates to ensure perfectly smooth, accurate edges. Each piece is numbered and transferred to sewing stations, where double needle machines assemble collars, hems, and sleeves under steady steam presses to preserve the shape. Once inspected, every garment is steamed, folded, sealed, and labeled for global distribution, completing wool's journey from open fields to the modern wardrobe. From the vast open pastures to the precision of modern textile mills, the journey of wool stands as a testament to the delicate balance between nature and technology. If you found this journey fascinating, make sure to like the video, share in the comments which part impressed you most, and subscribe to The Factorin to discover more incredible stories of how materials are transformed through human ingenuity and industrial craftsmanship.